All right, we're on to section 8.6 and or probabilities. So we're going to jump right into the first note card of the section, note card 284. This is the AND note card, also known as intersection, also known as multiplication probability rule. So there's a kind of a lot of information on this, just to get you to know that they all kind of mean the same thing. So AND means intersection, okay, an intersection of things. An intersection means only what is in common, what is common in both. So if I give you a list of numbers 1, 2, 3, 4, and a list of other numbers 4, 5, 6, what would be common would just be the 4. That would be the intersection. So intersection is what is in common in both sets. This is the notation for it. A and B is the same thing as A intersect B. This upside down U means intersection. So the word and this upside down U are the same thing. They mean and an intersection. And this is when we use the multiplication rule. This is called the general multiplication rule of probability. And here you go. You would just do the probability of the first event times the probability of the second event. This is for independent events. If they're dependent, it's different, but for right now, we're just going to talk about independent events. So you just simply multiply. So pause me and finish up note card 284. Now we're going to move on to note card 285, or the union, the addition probability rule. Or means union. Union is, the symbol is an uppercase U. So A or B is the same thing as saying A union B, union being that uppercase U. Union means everything in both sets. So if I have numbers 1, 2, 3, 4 in set A, and numbers 4, 5, 6 in set B, A union B would be 1, 2, 3, 4, 5, 6. And we wouldn't put the 4 twice. We're going to use the addition rule. And it seems really, really scary. But you just do the probability of A occurring plus the probability of B occurring, and you subtract off what's in common, so you don't double count it. This minus part looks really scary, but that's just what's in common. Like we wouldn't use the 4 twice in the example I just used. And in this last row is just using the intersection symbol. So pause me and finish up note card 285. All right, let's do an example of OR, of the union. Now remember, the union one, oh wait, where we are. The OR ones, we use the addition rule, okay? So, there's a spinner with 12 equal areas. All right. Here's the spinner. You wouldn't have to draw it. I just want you to see it. I'm getting this from Delta Math, okay? It's numbered 1 through 12. If the spinner is spun one time, what is the probability that the result is a multiple of 4 or union a multiple of 6? So first of all, we need to find multiples of 4. So 4, 8, 12, okay? And then what are the multiples of 6? So 6 and 12. And that's it on that spinner, okay? So what we would do using this formula is we would do the probability that it's a multiple of 4 plus the probability that's a multiple of 6 minus the probability that it's a multiple of 4 and 6, okay? Now, on this particular one, you could use your common sense, but I do want to show you how to use that. Okay, here we go. All right, there we go. I was trying to get that on there, but okay. So the probability that it's a multiple of 4 plus the probability that it's a multiple of 6 minus the probability that it's a multiple of 4. I'm just going to put a 4 like that. And multiple of 6. All right, so what's the probability it's a multiple of 4? There's 3 of them. That's 3 out of 12. Plus the probability it's a multiple of 6. There's 2 of those. So 2 out of 12. But I need to subtract off the common ones. Otherwise, I'm double counting. So what's common in both of these lists? It's a 12. So there's only one of them. So minus 1/12. Move this. Let's see. I know. I know. Y'all are enjoying watching me edit this. Of course you are. All right, so I'm going to put that right there. And so what does that give me? 3 12s plus 2 12s is 5 12s, minus 1 12 is 4 12s, which reduces to 1/3. So let's see. Now, the union of the sets, 4, 6, 8, and 12. There's 4 of them, which we figured out using the formula, and 4 out of 12 is simply 1/3. So I showed you down here how to use the actual formula because sometimes it's just not as easy as what this makes it look. Okay, so again, this down here was me using the formula on note card 285, but you also can do it like this up here where it's not as, this one's not as difficult, so it's a little more intuitive, and you're just going to go, oh, the union is 4, 8, 6, and 12 because union is all of it. Remember, union means everything in both. So 4, 6, 8, and 12, there's 4 of them because we're not double counting that 12 out of 12, or we can use this formula. So pause me and finish up note card 286. Now we're going to move on to note card 287, which is just another or union addition probability example using a two-way table. So you can also use a Venn diagram. In a certain Algebra 2 class, there's 28 students, 8 of them play basketball and 14 of them play baseball. There are 12 students who play neither sport. So look at this, it's not telling me who does both sports. So what is the probability that a student chosen randomly from the class plays basketball or baseball? This is an or, so it's a union, it's addition rule. So we can't simply just do 8 out of 28 plus 14 out of 28 because we don't know how many of those are common. So what you've got to do first is make a table with information given. So we've got students who play basketball, students who play baseball, and then of course there'll be students who don't play baseball, some that don't play basketball, and some don't play either. And we know there's 28 students. So notice how we set this up. Plays baseball, does not play baseball, then we have a total column. Plays basketball, does not play basketball, we have a total column. Now, we knew that there were 12, let's see, yeah, there's 12 students who don't play either. So it would be right here, does not play basketball, does not play baseball. We knew that 8 played basketball total, and we knew that 14 played baseball total, and we knew there were 28 students. So take a minute to see how we take the given information and plug into this table. Now the next thing you do is fill in the table. So like right here, you know that's going to be 14. And then you know that's going to have to be 2 because 2 plus 12 is 14. And that's going to be 6. And you just keep going. Okay? So here's the table filled in. And then we want the probability that they play basketball or baseball. So what would we do here? All right, so using the formula, probability that they play basketball or baseball is going to equal the probability they play basketball, addition rule, so plus okay, the probability they play baseball minus the probability they play both. So the probability that they play basketball and baseball. So that's so we don't double count them. Let's see. I'll make it like that. Okay, so looking at, geez Louise. Okay, there we go. So looking at the table down here that's completed, what's the probability that they play basketball? Well, let's see, plays basketball. It'd be 8 out of 28. 8 out of 28 is the basketball probability. Plus, what's the probability they play baseball? So that's right here, 14 out of 28. But then I have to subtract off the probability that they play both, so I don't double count them. So there's 6 of them that play both. So minus 6 out of 28, which would give me 16 28ths. 8 plus 14 minus 6, yep. And those both divide by 4, so it'd be 4/7 is the answer. Okay, so the answer is 4/7. This is another way to think about it. People who play baseball or basketball, there were 16 of them out of 28 because they're doing everybody except the 12 who play neither. And then they figure it out that way. So that's just another way to think about it. So pause me and finish up note card 287. I do feel like I need to explain a little better how they got the 16. They looked at this table and they didn't include the people who didn't play. So they did 6 plus 8, which is 14, plus this 2, which is 16. So that's where they got the 16 out of 28. See, that's why I like what I bolded right here. I like to use the formula because it can be confusing this way. Okay, so I'm really showing you 2 different ways to do it, but I prefer the formula way. Just like on the last note card, I prefer the formula way because trust me, that's going to help you. All right, now the next note card is 288, where we're going to move into and or intersection multiplication probabilities. Now let me just remind you, for the ands, it looks like an upside down U. It's called intersection, and we multiply, okay, for independent events. Okay, there's a spinner with 12 equal areas. Okay, so a same spinner as before. And the spinner is spun one time. What is the probability of the result of a multiple of 3 and a multiple of 4? So we need to find the multiples of 3 and the multiples of 4. And then this is an and problem. So we have to look what's common in both. So what number or numbers are common in both of these sets? That's the intersection of the sets. And it is just, we've got to find that intersection, and it is just 12. There's only one time that would happen out of all of 12. So your solution is 1/12. And you'll notice that for these and problems, I do not use the formula. You really just need to look at what's common in both and go from there. We will later possibly do some where we use the formula for the and ones, but more than likely it'll just wait till Math 3. All right, so another example of an and problem, and again, I'm not going to use the formula. We have an Algebra 2 class of 21 students, 7 of them play baseball, and 7 play basketball, and 8 of them play baseball, and there are 11 students who play neither. And so this is really similar to this other example that I did. And it says, what is the probability that a random student that's chosen plays both basketball and baseball? And the last one we did was or. Okay, it was an or problem. And those, I love the formula. Ands, not so much. Okay, so we need a table, and you fill in what you know. We know there's 7 total that play basketball. So plays basketball column, 7 total. Plays baseball row, 8 total. And we know there's 11 who don't play either, and we know it's a class of 21. So then we just go backwards and fill in that table. What's 21 minus 8? You put that there. That's 13. And then we can go and fill in the rest. So now, we've got to look for the ones who play both basketball and baseball. Okay, so that would be these right here. So it would be 5 out of 21. All right, so that's it. And you have a Delta Math assignment that is just like these, okay? And so take your time, look back over your note cards, and get it done. You guys are doing great. Keep it up. We don't have much longer.